Imagine, if you will, a universe contained entirely within you, trillions of stars, cells, each one a bustling metropolis of activity. Within these cities, countless smaller citizens, proteins, enzymes, molecules, have jobs to do. They are the builders, the messengers, the repair crews. This intricate dance of life unfolds every second, a silent, microscopic ballet that keeps you alive. It is a symphony of unimaginable complexity where every player has a crucial part. But what happens when this delicate orchestra is disrupted? An injury, a tear, a moment of damage sends shock waves through this cellular society. Alarms sound, chemical signals call for an emergency response. Specialized cells rush to the scene to patch the damage and clear away debris while builders lay down new collagen. This process, healing, is one of nature's most profound performances, a testament to resilience encoded in our DNA. But what if we could boost this internal repair crew? Give them a new set of instructions, a new tool? This is where our microscopic journey begins. In this grand cellular orchestra, some molecules are soloists while others are conductors. BPC-157 appears to be one of these conductors. Its full name is Body Protection Compound 157. It's a peptide, a short chain of amino acids. BPC-157 is composed of just 15 amino acids, a tiny fragment of a much larger protein, naturally found in our own stomach acid. Many peptides break down quickly in digestion, but BPC-157 remains remarkably resilient. That durability lets it travel and act in various tissues: muscle, tendon, gut, brain. Scientists synthesize this small, stable fragment to study it closely. Researchers now investigate the synthetic version with great interest. It's like a master key, a short biological code that can unlock a system-wide healing response. Unlike many substances with a single job, BPC-157 is multi-talented and mirrors something our bodies already make, a piece of innate biological wisdom concentrated for study. Exploring BPC-157 is part of understanding the body's own pharmacy. BPC-157 is a fascinating chapter in that story. We open new possibilities when we learn how to guide healing. We begin to ask, can we guide healing? Make it faster, more robust, more complete? How does a simple chain of 15 amino acids orchestrate such a complex healing response? The primary mechanism seems to be its effect on angiogenesis. Angiogenesis, the creation of new blood vessels, is critical because vessels deliver oxygen, nutrients, and repair cells. Imagine a torn muscle in an athlete's leg. The injury site is a scene of devastation, ruptured fibers, internal bleeding. The body's natural response can be slow, vessel growth is often a bottleneck. Early research suggests BPC-157 acts like a master foreman, signaling the body to accelerate the construction of vascular pathways. More blood vessels mean more efficient delivery of what tissue needs to rebuild itself: oxygen, nutrients, immune cells. This regenerative influence extends to tendons, bones, and especially the gut, the peptide's original home. BPC-157 appears to mend cellular junctions, reduce inflammation, and promote lesion healing in the gastrointestinal tract. It promotes fibroblast migration and collagen deposition, rebuilding the structural framework of new tissue. By acting on multiple fronts, building supply lines, repairing the gut wall, directing construction crews, BPC-157 behaves less like a single tool and more like a master plan for regeneration. The potential benefits of such a powerful healing agent are vast, and, honestly, pretty exciting. For sport and rehab, the implications are profound, shortening recovery time and getting athletes back to peak performance. Beyond elites, think about someone recovering from surgery or a sprained ankle. Fewer weeks immobilized means less pain, quicker return to life. Less time in pain, a quicker return to work and daily activities, a more complete recovery. Reduced inflammation is a major draw, calming the excessive response that causes chronic pain. Restoring gut integrity improves nutrient absorption, immune function, and overall well-being. However, we must temper excitement with caution. As of today, the vast majority of research has been in animal models, mostly rodents. Translation from animal studies to human efficacy and safety is a long, unpredictable journey. The peptide exists in a gray market as research chemicals. Quality, purity, and dosage can vary wildly. Without pharmaceutical safeguards, the user can become the guinea pig in an uncontrolled experiment. This frontier demands caution. Every great journey begins with a single step into the unknown. With BPC-157, we stand at the shoreline. We have only just dipped our toes in. The primary concern is the lack of extensive, long-term human clinical trials. We simply don't yet have a full safety profile. What are the potential long-term side effects of stimulating angiogenesis so profoundly? Could there be unforeseen consequences over many years? Regulators reflect this uncertainty. BPC-157 is not approved by major bodies like the FDA for human use. We have a compelling hypothesis and a wealth of preclinical evidence, but anecdote is not evidence. We need rigorous trials. We must build better ships, well-designed clinical trials, to make the journey and see for ourselves. The future of regenerative medicine is bright. Peptides like BPC-157 are leading the charge, but our path must be careful and methodical. It speaks to our quest for resilience, our desire to restore and overcome damage. BPC-157 is a distant, intriguing star we've just spotted. The initial readings are spectacular. Regeneration, recovery, resilience.